Okay, so in this video, we're going to look at the angle between two lines, the formula that is part of our coordinate geometry formula. It is on page 19 of the log tables. Here it is here. It tells me here that the slopes M1 and M2 are needed, and tan theta, whatever that is, that's the angle then that would be between the two lines. Okay, so I'm going to explain this formula in more detail. But this is where on page 19 of the log tables, this is where you're able to find it. Okay, so as we said, this is the formula, and the M1 and M2 stand for slopes, the slopes of the two lines, okay? And this will give me the angle between the two lines. The plus and the minus, by the way, this comes in because when you have obviously angles between two lines, you could be talking about this pink angle here or this yellow angle here. And in this case, and is in probably most cases, then one of them would be obtuse and one of them would be acute. And this is where the plus and the minus comes in, okay? Now, I don't want you to worry too much about that. The easiest way to kind of deal with dealing with obtuse or acute angles is to always take the positive value. Whatever you get here, always take the positive value, okay? And then when you're looking for the angle, you will always end up with the acute angle first. And then, of course, all you need to do is subtract the acute angle from 180, and you would get, of course, the obtuse angle. That is the way we are going to approach this. It's the easiest way rather than getting too caught up with the pluses and minuses and how it links back to the trig curves and everything. Let's just always take the positive value. And then if we want the obtuse angle, just take away the acute angle. Okay, we'll see this in play now in a minute when we delve into some examples. Okay, so let's have a look at this question here. Find the acute angle between the lines y equals 2x plus 5 and 3x plus y equals 7. So I've just written my formula here to one side. So again, the two bits of information you need to be able to use this formula is, of course, M1 and M2, and they're the slopes of the two lines, okay? Okay, so taking this line here, this is already set up really nicely to be able to pull out the slope because it's already in the form of y equals mx plus c, which means the coefficient of the x is the slope. So I'll call this one M1. It doesn't matter which way around you call them, M1 or M2 or M2 or M1 or whatever. It's just one of the slopes will be M1, one of the other slopes will be M2. So we'll call this one M1. That is the slope of that line there. This line, however, does need a little bit of rearranging. So again, we need to rearrange it in the form of y equals mx plus 2. So I'm going to need to bring the 3x over. And so my other slope, I'll call it m2, is the coefficient of the x here, which is minus 3. Okay, so now I'm going to put my information into the formula. So tan of the angle then, plus or minus, I'm putting 2 in for m1 minus m2 minus 3. It goes in for M2, of course. All right, I'm keeping brackets around it. It's best to do that, especially when you've got a subtraction up here. All over 1 plus, and this is 2 times minus 3. And again, the brackets will make sure that you do multiply them here. All right, so I'm going to evaluate all of this on my calculator. And I'm getting minus 1. So as I said, don't worry about that plus or minus at all just yet. But when I work out all of this, I am getting minus 1. Okay, so as I said at the start, the easiest thing to do is always take the positive value of this. So this is where the plus and minus comes in. You can use whichever one is going to give you the positive value. So in this case, we're just going to take the positive value. So we're going to make it a 1. The positive value is always going to give us the acute value. And this comes back to your trig graphs and your solving trig equations. And if you remember your unit circle, between 0 and 90 degrees, yeah, that's when, of course, your angle would be acute. But between 0 and 90 degrees, all of the trig curves would be positive. In other words, you get positive results. So this is why we're going to take this positive as a positive result. And then I know when I do tan inverse, I'm going to get an angle between 0 and 90. Okay, so the easiest thing to do is get that acute angle. So tan inverse of 1 gives me 45 degrees. So the acute angle is 45 degrees. That is what I was asked for in the question. But if I had been asked for the obtuse angle, I would still advise you to always get the acute angle first. And if I'd wanted the obtuse angle, I would just do 180 minus 45 degrees, which is 135. And that would be the obtuse angle, if that's what I had been asked for. Just a little note at this point, if you are looking for an angle between a line and the x-axis, okay, so obviously they'll give you more information than this in the question, but so the first thing you're going to need to do is pull out whatever the slope is of that line, and they'll give you information about that. But the other bit of information you're going to need is the slope of the x-axis. And the slope of the x-axis, the axis, of course, is a horizontal flat line, which means the slope of the x-axis would be 0, and you would input it as such. Okay, so just watch out for that. If you're looking for angles between a line and the axis, the x-axis, then the slope of the x-axis would be 0. And the other piece of information you're going to need for that formula is the slope of the line in question. Okay, let's have a look at this question. All right, if you're feeling confident, press pause. Otherwise, let's work through it together. So this time we're asked for the obtuse angle. But again, we're going to go ahead and get the acute angle first, and then it's really easy to work out the obtuse angle afterwards, okay? Right, so what we need, of course, for our formula is the slopes of the two lines. Okay, so I've got my formula written over here for myself, and now I'm going to look to pull out the slopes of the two lines. Okay, so again, I need to do some rearranging here. So let me bring over the x term and the constant. So I get this, and of course I need y on its own, so I'm going to have to divide across by 3. So that will be minus 2/3 is the first slope. Okay. Let's do the same thing here. We need to rearrange it. Again, I just changed all the signs there. So I have it positive, and now I'm going to get the y on its own. So I'm going to divide across by 2. That, of course, is a 1x. So when I divide by 2, it's going to be a half x, and then 3/2. And now I can pull out the coefficient there, and I'm going to get my other slope is a half. Okay, let's put it into the formula. This is going to be a little bit nasty in terms of your inputting fractions within a fraction. But don't worry, your calculator is going to do all the hard work here. Just make sure you have inputted it correctly into the formula, put brackets around everything, and then we can just type it in to the calculator as we see it there. Okay, so remember, we're going to ignore the plus and minus. We're just going to do all this number work here. And I'm getting minus 7/4. So again, we will take the positive value, which is 7/4, and then we will do tan inverse to get my angle. And it's working out to be 60.255. I'm going to round that to 2 decimal places, given that it didn't specify in the question. I'll go with more accuracy rather than less. So that it is the acute angle to 2 decimal places. I, of course, need the obtuse angle. So that's going to be 180 minus 60.26. And that is 119.74 degrees. Okay, there's 2 parts to this question. So let's have a look at the first part first. Find slopes of the two lines which make angles of 45 degrees with the line x minus 2y equals 1. Okay, so this time we're asked about the slopes and we're actually given the angle. Okay, so let's take a look at our formula again. Okay, so here it is. So what I have here is I have an angle, which I'm going to be able to input here. And the other thing that I am going to be able to pull out is, of course, the slope of this line. And then that will be able to be inputted in for one of these slopes here, which will then leave me with only one unknown, all right? And the plus or the minus is what's going to give me two different values for the second slope. Okay, so let's have a look and pull out the slope of this line. That's the next thing we need to do. So if x minus 2y is equal to 1, let's rearrange that. Let's change the signs, and then of course remember, let's divide everything by 2. So that's going to be a half x minus a half. So the slope of that line, and we'll call it m1, is a half. So that's now what I'm going to be able to input in here. So that means we have enough information in the question to pull out and put into the formula to leave me with, of course, only one unknown. The only thing we don't know then is the m2. And as I said, the plus and the minus is what's going to give me two slopes of the two lines. Okay, right, let's input in the information. Okay, so this is what I have. Now, just for ease of working with the algebra of this, I'm just going to remove the 2. We'll just call it m, okay? It's the only thing we don't know, all right? So let's not confuse ourselves too much. We're just going to call it m. We need to get the values. There's going to be two values for m, but we need to figure out what they are, and they're going to be the two slopes, obviously, of the two lines, okay? So let's just call it m because, as I said, just for the ease of manipulating this and working with the algebra of it, it's easier to kind of deal with m than an m2. Okay, so now let's first of all evaluate tan 45. So tan of 45 degrees, and make sure your calculator is in degrees because obviously the angle is in degrees. So we're getting 1. And a half times m is a half m, okay? Now, don't worry too much about this plus or minus for the moment, okay? I know that makes it a little bit confusing. Let's first of all get rid of the denominator, which is always the most pressing thing to do when you have an equation like this with the denominator. Let's get rid of the denominator, and the way we always get rid of denominators is, of course, we multiply both sides by them. So I get this, and then all of that will cancel with all of that. And on this side, I'm left with 1 plus a half m times 1, which is, of course, 1 plus a half m. And then I'm left with plus or minus, and of course, I have a half minus m. I'm just going to put that in brackets here on the right-hand side. Now, at this point, this is when I'm going to split this up into two separate equations. Okay, so 1 plus a half m, and I'll take the positive version, okay, and then 1 plus a half m, and I'll take the negative version, okay. And this is why it's important to keep this whole top part in brackets now, because we'll multiply in by the plus first, and then we'll multiply in by the minus next. Okay, so when I do that, then I get a half minus m on the right-hand side here. But of course, multiplying in by the minus on this side, I'm going to get minus a half plus m, when the minus by the minus will give you the plus. Okay, so here's my two equations. Now, rather than deal with these nasty halves everywhere, what I'm going to do is I'm going to multiply across by 2 to make life easier for myself. And what I get then is 2 times 1 is 2. This cancels with this, so I'm left with just an m. This cancels with this, so I'm left with 1, and then minus 2 times m is minus 2m. And here I'm left with 2 plus m is equal to minus 1 plus 2m. Now, getting the m's on one side, I'm going to add 2m to both sides here to get rid of the minus 2m on that side. And I'm left with 2 plus 3m is equal to 1. Subtract 2 for both sides. And I'm left with 3m is equal to minus 1. Therefore, m is equal to minus 1/3. On this side, I'm going to I'm going to take away the smaller one because that'll just not leave me with negatives. I prefer to do that when I have an unknown on both sides. I prefer to take away the smaller of them, or the fewer of them. So I'm going to take away m from both sides, and that leaves me with 2 on the left hand side and just an m on the right hand side with the minus 1, of course. Now I'll get the m on its own by adding 1 to both sides. So I'm left with 3 is equal to m. So here's my two slopes. So I have m is equal to minus 1/3, or m is equal to 3. So there's the slopes, the two slopes of the two lines that make angles of 45 degrees with the line x minus 2y equals 1. Okay, now let's go back to the question for the second part. Hence, find the equations of the two lines if they go through the point 2, 3. Okay, so our two answers were, of course, minus 1/3 and 3. They're the two possible slopes. And the point is, of course, 2, 3. If I want the equations of the two lines, I'm going to look at this formula. Y minus y1 equals m times x minus x1. And the first thing I'm going to sub in is when the slope is m is equal to minus 1/3. And then I'm going to sub in when m is equal to 3 for my second equation. Okay, so here we go. So on this side, I'm going to multiply both sides by 3 to get rid of that divide by 3 on the right-hand side. And I get 3 times y minus 3 on the left. That cancels with that, so I just have minus 1 times x minus 2 on the right. Okay, so that'll be 3y minus 9 is equal to minus x plus 2. And then tidy up the number work. Let's add 9 to both sides. I get 3y is equal to minus x plus 11, which is correct, but I'm just going to rearrange it. It is also equivalent to minus x minus 3y plus 11, or the way they tend to like it is in the form ax plus by plus c. They often like to make the x term positive, so I'm just going to change all the signs. This is also, these three manipulations are all equivalent equations of the line. And on this side, I end up with 3x minus 6. Again, tidy up the number work. I'm going to add 3 to both sides here. And I end up with y is equal to 3x minus 3. So that is correct. Again, I'm going to do a little manipulation and bring over that y term. So I get in the form ax plus by plus c equals 0. And there's another correct version. So we have our two equations of the two lines. Another important note I just want to highlight here as well is when we have dealt with slope of a line before, so say I have a line going through these 2 points, we've often looked at the rise over the run to give you the slope, the length of the rise over the length of the run, yeah? So the slope is equivalent to that. And of course, if it's going upwards like that, it is a positive rise over run. Okay. The other thing I want to highlight here that can be often linked and can come up in questions is when I analyze the rise over the run, I am, of course, kind of making this right angle triangle because I'm analyzing the length of the rise and I'm putting it over the length of the run. The other thing that I want to connect at this point with a right angle triangle is if you're looking at the angle here, right? That is the opposite side and that is the adjacent side. And the slope of the line, therefore, is linked to tan of that angle, which of course is opposite over adjacent. And that is, of course, the same as rise over run. So that means that the slope of the line is the same as tan of the angle there. Tan of that angle there will give you the slope of that line. So watch out for the little connection between tan of the angle and slope. Okay, let's try this final question. So find the equations of the two lines through the origin which make angles of 45 degrees with the line 2x plus 3y minus 4 equals 0. Okay, so this isn't broken up as nicely as the last one was, okay? But again, the minute you see that they're giving information of an angle between lines, then you know it has to be this formula. So get that down for yourselves straight away, okay? So as we saw already with the last one, if you want the equations of two lines, the first thing you need is the slope of those two lines. So that's what we have to work out from this formula first. And so we have this piece of information to go here. We're going to use this line to get the slope, so I can put it in for one of the slopes here. All right, pause the video if you feel confident to give this one a go. It is very similar to the previous example. It's just in the previous example, we had kind of a little stepping stone to the method. Okay, here we're delving straight in to find the equation of two lines, but you need to recognize the first part of that is to find the slopes. So rearranging my line here, I get the following, and I'm going to need to divide by 3 to be able to pull out, of course, the coefficients. So we'll call it M1, and M1 is minus 2/3 is the slope. And of course, this is what we have. And again, just for ease of the manipulation, I'm going to take off the M2 and I'm going to just leave it as M. And solve for M, and I'm going to get two equations dealing with the plus and the minus. So tan of 45 degrees, do that on your calculator, you're going to get 1. So I end up with minus 2/3 minus M all over 1 plus minus 2/3 M. And my next step, of course, is to get rid of the denominator, so I'm going to multiply both sides by that denominator, so it cancels there on the right hand side. And of course I get this, and now I'm going to break it apart into two separate equations. And so we get either plus all of this on the right hand side or minus all of this on the right hand side. And you see I've put in the extra brackets there because that minus is going to affect every term that follows. And so I get this. And the minus, the effect that the minus has here is, of course, the minus by the minus will give you a positive 2/3, and the minus by the minus M will give you a plus M. Now what I'm going to do is I'm going to multiply across by 3 to get rid of the divide by 3 all along. And that gives me 3 times 1 is 3. That cancels with that. I'm left with minus 2M. And that cancels with that. I'm left with minus 2 minus 3M. And on the right hand side, 3 times 1 is 3. That cancels with that. Minus 2M is equal to, that cancels with that, 2 plus 3M. Adding 3M to both sides here, I'm getting 3 plus M is equal to minus 2. And then take away 3 from both sides here. And I'm getting M is equal to minus 5. There's one of my slopes. Adding 2M to both sides here, I get 3 is equal to 2 plus 5M. And then taking away 2 from both sides, I get 1 is equal to 5M, which of course gives a slope of 1/5. So there's my two slopes, minus 5 or 1/5. So I'm going back up to the question now. Now I want the equations of the two lines through the origin, which of course is the point 0, 0, which make angles of 45 degrees with the line 2x plus 3y minus 4 equals 0. So the two slopes, of course, I have m is equal to minus 5 or m is equal to 1/5. And of course, this is my formula for the equation of a line. So subbing in my information, there's the first line using the first slope and the second line using the second slope, and both of the lines go through the origin 0, 0. And I get y is equal to minus 5x or y is equal to 1/5 x.